Hi, let's come back after 5 minutes break. Then we start the section 3, axioms of probability. To understand the terminology, axioms, let's try to understand some other terminologies, okay? And I also translate in Chinese. If some of you may have some interest to learn a little Chinese terminology, okay, Chinese terminology. So what does the answer mean? This slide, all those statement, the explanation, definition, coming from Wikipedia, okay, Wikipedia. And I just used the Wikipedia several days ago, and the coronavirus disease is a hot topic, and it's on the top of the topic or the terminology people searched on the Wikipedia. But it's true, right? It's true. You know the situation is going on. All right. So the axiom, okay? The axiom. Some people get a little problem. It's loading. So the axiom means in Chinese we call it 公理. 公理. Okay, what does the axiom mean? It's a statement that is accepted without proof and regarded as fundamental to a subject, and it's self-evident, which means if we call it an axiom in mathematics, that is the statement you accept it's true without any proof. Okay, and actually I guess you heard some axioms, you know some axioms from geometric subject when you were in high school. For example, it is possible to draw a straight line from any point to any other point, right? So this is like we understand two different points in the x or y plane can determine a straight line, but we never prove it. This is the self-evident statement. We accept it without proof. We accept it, it's true. So there are some basic idea when you were accepted in your high school. It's true, the statement. That is called the axiom. Okay, axiom. So it's self-evident. So here, this section, the answer of the probability we are going to talk about, it means we are not going to exactly prove it. Okay, we are not going to exactly prove it. But some people may ask, we did some proof before, right? Either in calculus, linear algebra, or statistics. What are those we call? It's a different terminology, theory, right? We did some proof of the theory in the calculus subject. What is the theory means? First, in Chinese, it's called 定理. 定理. The first one is 公理. Second one, theorem called 定理. 理, they are both 理, but different 理. First one is 公理, self-evident without proof. 定理, what is 定理? A non-self-evident statement that has been proven to be true either on the basis of axioms or other theories. So we need to prove the theory. The theory is something we need to prove. How can we prove it? We are going to based on some axioms we know or some other theories we have already started before. Make sense? So theory need to be proved, okay? Need to be proved with some other axioms or other theories. That is 定理. I think we are more familiar with 定理in the calculus course, right? In the calculus course. Now, next one, preposition, okay? Preposition. That is called 性质 in Chinese. 性质. What does preposition mean? A theorem of lesser importance. It connotes a statement with a simple proof. Okay, connotes a statement with a simple proof. If you read some advanced level of mathematics textbook, You might see those, okay? You might see those, and sometimes you got confused with those kind of terminology. Actually, they are totally different, okay? They are totally different. Axioms, we haven't talked about any axioms in the college math subject so far, okay? We will start here from the probability, but we have seen a lot theories, okay, like the fundamental theory of calculus we discussed in the calculus. Proposition, actually, we also see some proposition, okay, propositions. It can be proved in a simple way. And actually, there are some other terminologies, okay, lemma, 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 or corollary, or hypothesis. Hypothesis, we will see this terminology frequently in the statistics part, okay. Now, you can also search the Wikipedia to refer to those, what does those terminology means, okay. Lemma is also kind of theory. It's a small one, but it's less useful, okay. It's less useful, and we need some lemma. We form some lemma to prove the theory. That is its function, okay. And corollary will be some theory in the special case, okay, in a special case. And hypothesis actually is kind of assumption we need, okay. What's an example of proposition? We will see it later in probability subject, okay. We will see it later in the probability subject. There will be some proposition, okay. It's less importance, and it's based on some theory, okay. It generated from some theory. We will see the proposition. So it's interesting, okay. It's interesting to know those terminology, no matter which mathematical subject you took. And it's interesting to know it's Chinese, okay. 公理、定理、性质, and this one is called 引理. Corollary is called 推论. Hypothesis is called 假设. It's the same interpretation of the assumption, okay. Now let's start with the topic in our section today. Now let's consider the relative frequency, okay. We have already seen the relative frequency in statistics, right? It's the frequency in one category divided by the total number of the outcomes. So let's consider an experiment with the sample space S. So experiment is repeated, performed under exactly the same condition, and it's repeated n times usually. So what is NE represent? Of course, E is the event, right? Event E. So the NE means the number of times in the nth repetitions. What is the repetition? Which means the experiment performed under the same conditions. So in the n repetitions, the number of times the event E occurs, okay. This one represents in the nth repetitions the number of event E occurs. We know event E will consist of some outcomes, right? Event E is a subset of the sample space. And then PE, okay, PE, capital letter P, okay, capital letter P. This is also the notation to represent the probability in our course. The probability of the event E is defined, okay, is defined in this way. How can we understand this one? Actually, NE over N, NE over N, this is the relative frequency, right? This means the relative frequency for the event E. Relative frequency for event E. The relative frequency of the event E, that is just the number of the event E occurs. the number of times event E occurs, divided by the total number of the n repetitions of the same experiment, right? The same experiment repeated and under the same condition. Now, how can we define the probability of the event E? We let this n approaches infinity, which means we repeated the experiment infinity times under the same condition. So this term is called the limiting relative frequency. So the probability defined as somehow the relative frequency, but the repetition should approaches infinity. Okay, should approaches infinity. That is the limiting relative frequency we're talking about. So we will define the probability of the event A as the limiting relative frequency. So the PE, the probability of event E, actually can be interpreted as the limiting proportion of the time that E occurs, right? The limiting proportion. Limiting, okay? Be careful. It is the limiting relative frequency of the event E. Make sense? So it's the limiting relative frequency. And how can we understand it? It's a limiting case, okay? How can we understand it's a limiting case? As an example, okay? As an example, the example flipping. Let me just explain. Flip a coin. Flip one coin, okay? Flip a coin. One coin. And if the coin is balanced, okay, we should mention it's balanced on both sides. Balanced on both sides. We have head or tail. If we flip a coin, the experiment is flipping a coin. Then it's balanced on both sides. So now I'm going to define my event E is head. Okay, event E should be head. You get the outcomes head. Just one coin. And then I'm going to define my event F is tail, right? Just one outcomes. Now, can you tell me what is the probability according to the limiting relative frequency? What is the probability you get the head? Which means the probability of event E, right? The probability of event E that implies the probability getting the head. And I believe most of you know that it's 1/2. What is the probability you get a tail? It's 1/2. How can you understand this is 1/2? So this one means the how can you understand the probability with the limiting relative frequency? So that means you repeat the experiment. You flip a coin n times, okay? N times. You count the number of the head. You count the number of the head. And then divided by the total number you flip the coin. For example, if you take your n is 10, but maybe the tail, the head occurs is not 5, right? If you repeat the experiment, flip the coin 10 times, we're not so sure the head will occur 5 times. Maybe it's not. It's not 5/10. Then I increase my n 100. Maybe not. Maybe it will be the number of head occurs. The number of event E, the head occurs will be around 50. Maybe 49 or maybe 52, but it's not exactly 50, right? It's not get 1/2 exactly. As what we know, actually, we have the idea the probability will be 1/2. Then how can we reach this 1/2? If n is 10, if n is 100, we are not so sure the number of the times, the number of head we got is the is the 50 is 5. Now we increase my n, okay? We increase my n 1 million. No sound? No sound at this moment? Sorry. Let me hold on, okay? Let's hold on.